So for the last parts, I'm just going to give some other details about these graphs that we just talked about. And we'll see some precise examples in our region, how we did it. And so just to give you some like peer-to-peer elements about this data, about this data representation. So within our region and in our agency, we are responsible for a kind of data center, an observatory. So we gather data, we create some data, and we publish. I mentioned the reports before. We also create various maps on topics, and of course we produce the diagrams I showed you, and we have an external tool, Territory, which helps us give access to all these data, all these representations, the maps, to all the actors within the region. So I will just give some details about those different elements. So when we talk about creating graphs, of course, we are going in the regional observatory, which is called Auvergne. We are going to create a lot of graphs. So I can show you. I showed you before a a report for a specific territory, but we also create like a report for the overall region. So you have smaller reports that gives access to maps with elements, for example, climate related, or on the water stress, the air quality, and etc. You have the access to the GHG greenhouse gases emissions, and the potential carbon storage, the pollutants emissions once again, etc. So creating these reports, of course, you need to gather the data, you need to create the graphs, and create the data tables. But you also need to be sure, as I mentioned before, that the end users are going to be able to use your data and to use your graphs. And so that's why we always propose the data tables as well as the graphs, as well as the final reports. So people have access to the raw data that they will be able to use for other, I don't know, operations, for other communications operations, or maybe some planning or some other elements. But also we give access, of course, to the report with the good graphs that we produced. So most of the graphs are developed using Excel, but sometimes we want to make the graphs more interesting. So for example, here, for this graph, we created the main graph in Excel, and then we made it more attractive using Adobe Illustrator to be sure that the message would be easy to understand. For example, here we have a circle, which area is depending on the value, and then we just have the distribution between the different sectors. Here we just have like a very quick number which gives the trend about the GHG gas emission, greenhouse gases emissions, and we give just the small trend of -3% between 2015 and 2019. So just to illustrate the fact that we are not quite ready to achieve our goals in terms of greenhouse gases emissions yet. For this graph, here you have the distribution of electricity production between the various commodities, and it was created using Adobe Illustrator from the start. So you have the value in 2015, then 19, 20, 2023, and then the goal that was set in 2030. So just to give an idea of where we are currently and what was the objective. So what is the path to access to go through to reach our goals. just to give you an example of before and after. For example, here you have the distribution of air pollutants in the different sectors. And in Excel, we have something like that. And then we go through Illustrator and we have something like that, that has exactly the same information, like 96. Well, it's not the same information because it's 2 different years. So sorry, but and then you have the information is more easy to read. For example, we use the same icons than we used before here, for example, or here, for example, in this graph. So we have like a common graphical identity that is easy to understand, and we will also use the same colors for the graphs, the circles, sorry, and the pollutant concerned. And finally, we'll increase the size of the numbers so the user can read them easily. So that's like most, that's some example about graphs. We also create maps, of course. So we use QGIS, which is free and open source. And of course, it requires some learning to master this tool. But I think there are plenty tutorials online that you can read and or watch to be able to create maps. And normally you should be quite easily, I guess some of you already use Quantum GIS. And so creating map is really useful in our region for temperature evolution and differences between the different areas of the region, and also to present the renewable energy potentials, which is very a key point in our region for local authorities, because they need to create plans to use this potential. Of course, so of course they want to know what are the potential in their territory. So what we will do when we use GIS tools, we want to be able to have multiple indicators. So each indicator will have a layer, specific layer, and we want to be able to gather them at some geographical level, for example, a department or county. But at the same time, we don't want the message to be too spare or hard to understand. So we want to have a message which is quite clear. So first, for example, here we want to have 3 indicators gathered at the same time: temperature related, summer days, which show a very strong high temperature, and frosting days. And you have the evolution between 1960 and 2019 for each sub region of the regions, so the department or county a little bit. So you have the regional average, and then you have for each department which was the trend in this period. Of course, you see that globally the trend is the same everywhere. So you have plus a lot of summer days, minus a lot of frosting days, icing days, and then you will have plus 2 degrees, of course, almost in this period. But you are easily able to understand to watch the differences between the territories. Another map that we created is a map about the biogas use potential. So each group of cities is represented here, and each one has a graph between the different sources of biogas production. So you have we talked about food, animals waste, green waste, waste from the households, small groceries, and agroalimentary industry, etc. And so each territory has a distribution of the estimated potential. So you see that, for example, you have many agriculture region here, a great agriculture region, and here also. So of course, the greatest part of potential will come from agriculture. And here you have catering, and that's why you have the brown part. And here you have big cities, so you have also a big part from households, etc. So it gives quite quickly, and it was created using quantum GIS, and it gives quickly a good overview of this potential biogas production. And the final map I wanted to show you is a very different kind of map. It's a map about the wind potential areas. So you have different colors from green to black. And these colors define whether you have constraints applying to the territories or not. So like black is not, it's not possible to develop a wind projects, and green is no constraint. So we removed any areas that are linked to airport, to military zones, to any kind of constraint that are in the law and that constrain the wind potential. And then we added some rules about like the cities proximity and the I don't know, natural parks, etc. So you can see that the areas that might be developed are quite limited, but it still gives an overlook of where it could be interesting to make plans or to propose projects to maybe funds to develop wind plants. Okay, so that's it for maps. There are a lot of tutorials online if you want to dig in quantum GIS or ArcGIS, but it's very useful to have like a summary, summed up representations. I mentioned before Sankey diagrams, and so to create a Sankey diagram is quite easy. You have to create a structure. So I talked a lot about the fact that when we look about, I can take back the example from Marlene. When you talk about Sankey, first it requires describing the overall structure of the system. So sorry, no, it's not the right slide. This one. So first you need to describe the nodes of your system and which are going to be the links available. And then once you have described it, so it's quite a lot of work, you will just need to provide for each flow from where it starts, where it goes, and what is the weight of the flow. So it's just the value, for example, of the energy flow. So it's quite easy once you have the structure of your diagram to create it and to fill it with the data. So for example, in the case I mentioned before from Terhistory, we created the overall layout using the Open Sankey library. So you can go to the website opensankey.fr, for example, if you want, and then you can create your own graphs and move them, and then decide which flows you will create between which nodes. And then once you have done that, you have your layout, and you can just automatically fill it with any data from the region that you want. So that's why when you go on the website I mentioned before, territory, and you select any kind of, I just select a random territory. For example, I will select, I don't know, a small group of cities near Lyon, and you will be able to access the energy layout. It's automatically filled with the data from this specific territory using the layout I created. So it's quite, it's once you have done the layout, once you have defined the nodes and the flows, it's quite easy to fill them with data. You can also use the Sankey software, which provide an offline tool to create Sankeys. It's quite good also. We use it a lot in our agency, and it's just not useful for our terrestrial case because it's not online, so we cannot use it.